So we're live now, Papa. Okay, hold on there.
They said you wouldn't make it so far.
Are you interested in finding a school to enhance your education? Not sure where to start? Well, today your search is over. CDP Maths Lab eSchool offers classes for C.S.E.C, CAPE, and GSET subjects, along with training in early childhood education and data operation. Listen to what CDP Maths Lab students have to say about their most fulfilling experience.
While I was attending, it was almost the best experience I ever had. Like I was in class, but I wasn't. I would give the school the full 10 out of 10 because the teachers take the opportunity to help the ones that really needed it. To the upcoming students, this is the best decision you have made and it will benefit you in the near future.
Talk to your soul and say, I can.
CDP Maths Lab eSchool was founded by Ronique Bernard in August 2009 with a vision to see our students receive a solid education with an emphasis on developing their cognitive skills. The school is committed to developing individuals who will have a positive impact on the society.
The class it really helped me, and if you are going to C.S.E.C, I really recommend this class, so you could always give it a try. The prices are really reasonable, and it is really worth it for online class. Like myself, you would be proud because on that day or on that night when results are out and you log in and you open your results, that feeling, it really is great. It is more of an experience that you would really want to relive.
Of course, I went through it and I passed my exams, so I would highly recommend this to anyone. If you have a problem or so, they will take their time out. They will take their time out to tell you. Plus, they have history of also past students who have also passed their exams in once.
I have been attending for 6 months, and my most fulfilling moment would be the interaction between the teachers and the students, as the environment is very comfortable and welcoming. On a scale of 1 to 10, with 10 being the highest, I would rate this institution, along with the teaching techniques, skills, and tolerance of the teachers, a perfect score of 10. If I had the opportunity to recommend someone to this class, I would, because I can assure you that you will leave 10 times better than how you had entered. Now that I am leaving, one thing that I would recommend is a classroom interaction, at least twice a month, as some students tend to do better with face-to-face interactions. This program would be the best decision one could choose, as the teachers are excellent at what they do, and they will go to the extreme to ensure that you understand what was taught, even if that means staying up with you all night. To CDP Maths Lab. Thank you.
Despite his late start, Sean Day was able to successfully complete his exam.
Trust me, it's a really good program, because if I entered a month before exam and I passed the exam, that says everything for itself. The program speaks for itself practically then.
Just start to believe.
CDP Maths Lab eSchool is convenient and economical. We provide flexible learning options in a relaxed environment. With over 80% pass rate, we offer free demo classes before payment, one-to-one interactive tutoring, clinical teaching sessions to strengthen weak areas, and step-by-step video and worksheet exercises.
Okay, good night, everyone. Good night, O'Shea. Good night, Tangini. And of course, good night, Mr. Foster. Good night to those persons who are viewing from the CDP Lab YouTube channel. I want to say a special good night to Teresa Powell. Good night to Alicia. And good night to all other persons who are just coming on. At the beginning of our class, we normally invite the presence of God before we start our program. So we welcome you to participate and to, prepare yourself for tonight's class. Now, I selected this passage of scripture deliberately. We are in our time of study. We are studying, we should be studying, and of course, some of us needs a kind reminder. So one of the wisest man, human being ever on earth, Solomon the wise, he wrote this passage of scripture. He was inspired by God to write this. Proverbs 14 verse 23 that says, in all labor, and note the adjective all, right? All, which suggests even in your studying, even your practicing mathematics, good, is a form of labor. So in all labor, there is profit. In all labor, there is profit. And we know what profit is. Where it is maths class. Profit is something that you what? Gain. So when you invest your time, good. When you invest your time, you will gain a profit. Good. So investing your time, you will benefit, you'll gain a profit. Now it's time. If you have not been investing your time and energy in preparing for your exams, then you'll get a loss and not a profit. So God is saying to us, in all labor, there is profit. But on the contrast, idle chatter leads only to poverty. So just in case you might be wondering why we are poor, it could be that we have been idle. We have been idle. Good. So I am saying that in all labor there's profit, but idle chatter leads only to poverty. So, which do you prefer? To get a profit as in a grade 1, because this is the only grade we are preparing for, grade 1. That's why we have Mr. Foster here as well. The only grade that we're preparing for is a grade 1. But you have to put in the time and the energy. All labor. In all labor, there's profit. But idle chatter leads only to poverty or failure. Please bear this proverb in mind. So as we listen to a part of our theme song, then I'm going to ask Tangini to pray for the class as we proceed. So after the song is played, then Tangini will ask his prayer. Thank you.
I love you, Lord. Oh, your mercy never fails me. And all my days I've been held in your hand. From the moment that I wake up till I lay my head. Oh, I will sing of the goodness of God. 'Cause all my life you have been faithful, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. I love your voice. You will lead me through the fire, and in darkest night, you were close like no other. I've known you as a father, I've known you as a friend, and I have lived in the goodness of God. Yeah. And all my life you have been faithful. Oh, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. Yeah. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. Oh, your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running, it keeps running after me.
Jangini. All right, I'll pray, being that Tangini background is not appropriate. Let us pray. Loving Father, we give you thanks, dear God, for this opportunity to be able to teach and to learn in this fashion once more. We thank you for the goodness that your goodness that you're allowed to keep running after us. And Father, we ask that you'll forgive us now for our sins that we have trespassed against thee, as we forgive those who have trespassed against us. Father, we want to put before you once again the students who are in Zoom, the students who are viewing from YouTube, and the students across the Caribbean who are preparing for exams. Some are still in limbo, some are still wondering if they should defer the exam, yes or no. But for those who are working, dear God, and for those who are praying and depending upon you, dear Father, I pray, dear Lord, you'll hear their prayers, search their hearts, free them from anxiety, and give them confidence. Lord, remember Mr. Foster and his family, his daughter and his father. Pray, oh God, I give you thanks for having him accepted to be a part of this program. Father, I pray that you bless him tonight. And may you use him greatly as you have used him last week. May he continue to do the job that you have called him to do. And be with us now, we pray. In Jesus' name, amen.
Amen, amen, amen.
All right. Let me do the introduction, sir.
All right. So,
Okay.
thank you for that introduction,
All
Sir
right.
Bernard.
All right. Hold on, Mr. Foster. Hold on.
Right.
All right. So good night to you all. I'm seeing Tangini. I'm seeing Nikosha. I am seeing Lexi. And I know that. Okay, good. So I want to say a special good night to you guys, and also a special good night once again to all our 11 persons who are watching now from YouTube. And we just want to say thanks again to Mr. Foster, our presenter for tonight. And Mr. Foster decided to give you guys, it wasn't a plan of CDP Labs to really give you guys on YouTube any Monday in May, but Sir Foster decided to give you Mondays throughout the rest of the time until exams. So we say thanks to him for that. And I think you should say thank him for that as well. So on Monday nights, we'll continue to go live throughout for mathematics classes. So at this time, we're going to ask to share the link. And if you're there, if you have not yet subscribed, you know that you should subscribe so that you get to see Mr. Foster on Monday nights. And of course, we have our English language class. We apologize for last week, Tuesday, but English language continues to stream on Tuesday. And of course, human and social biology. We have two Wednesday nights remaining for streaming. So get your pencils, get your paper, get your book, get your calculator, get everything you need in order to participate in tonight's class. So over to you now, Mr. Foster.
All right. So again, a wonderful good night to everyone here in class. Miss Martin, Miss Lexi, Miss Tangini. I think that's Mr. Nikosha.
No,
All
Miss
right.
Nikosha, Miss
Miss
Nikosha.
Nikosha, sorry, Miss Gooden. So a good
Mhm.
night to all of you. And as well, I just want to say a special good night as well to everybody who is listening in live on YouTube. So you know how we do this thing. We're gonna do it the same way how we did it last week, which means that we're giving everybody a chance to participate. So for those in the YouTube chat, of course, you know that when the questions are asked, you are also allowed to use your chat right there and to give your answers, and you will be acknowledged as well. All right. So let's get straight into it. Let me start by just sharing my philosophies about mathematics quickly. All right, so here we go. All right, so as I always say, and you guys will hear me say this regularly, questions change, but the principles always remain the same. All right, so it doesn't matter how difficult a question looks, how easy a question looks. Once you follow your principles, you should always be able to get your solutions confidently right or confidently wrong, but always be confident. A lot of times we doubt our ability to do mathematics, and that's the reason why we're not able to perform as well as we should and as well as we know we can. So let's just all try to build our confidence and believe in ourselves. All right. So that's a very important thing for you to know. You have to build your confidence, you have to believe in yourself. So we're going to go straight into it. So last week we started with a little introduction into bearings. And so this week we're going to start by doing a quick review question and then going into some harder exam style questions. All right. And so students should be able to display a knowledge of your trigonometric principles and solve questions involving bearings. So let's go through this review question right here. And it says, use a sketch to help you answer the following. The bearing of a point K from a point L is 164 degrees. Determine the bearing of L from K. All right. So I wonder if anybody remembers what we're supposed to do here. If anybody remembers the principles that we're supposed to follow, can anybody tell me what's the first thing that we're supposed to do? The first thing we do is try to identify so either in class here or in the YouTube chat. Anybody remembers the first thing we're supposed to do is to try to identify the what? What part of it? So they say determine the bearing of L from K. What does that word from help us to figure out again? Miss Tangini, you think you want to help us? Or Miss Martin? Miss Lexi? Do we remember this one here?
So starting point.
The starting point. All right, well done. So the word from helps us to figure out our starting point, and we always start with our starting point. So what is our starting point here? From K. All right, it says from K, so our starting point is K. So let's start with our starting point K. After getting our starting point, what do we do again? Remember that we're supposed to now draw the north line. Remember that we need to know our cardinal points, north, south, east, west. Remember 0, 90, 180, 270. What is the angle that they gave to us? 164. So if we remember what we did last week, we would remember that 164 has to come between which two? East and south, because east is 90 and south is 180. So our line needs to be somewhere down there. All right, so we draw our line somewhere down there, and that is where our L is. And then the angle north clockwise. Remember, you always use your 3 digits. And so all of those principles remain exactly the same. Nothing is going to change. The question now says determine the bearing of L from K. Right? So determine the, oh, hold on. It says the bearing of a point K from a point L is 164. So the first part, L is the starting point, K is the ending point. It now says determine the bearing of L from K. So for the second part here, K is the starting point. Draw your north line, that's your north. And then what do we do? North clockwise. That means that this is the angle on the outside that they want us to find. So if you remember the principles from last week, these two angles on the inside are called what type of angles again? Inside, interior, co-interior, and co-interior angles are supplementary. Remember, supplementary means add up to 180. So if we want to get this and these two add up to 180, take your 164 from 180. My answer is 16 degrees. So right here is 16 degrees. Remember, you always have to use your 3 digits, so you have to use 016. If you stop right there, you'll probably get like 3 out of the 5 marks or 2 out of the 3 marks, depending on how many marks the question is given to you, but you're not going to get full marks because you have not fully answered the question. The question is asking you to determine the bearing, and the word bearing is representing an angle. So once they ask you for the bearing, they're asking you for an angle. The bearing of L from K is this angle on the outside here, and we still have not found out. So how are we going to find that one now? We now use our next principle, angles at a point at up to 360 degrees. So if this is 16 and we want to find this piece out here, we take that 16 from 360 and we get our answer 344 degrees. And that is the actual answer to the question. All right, good evening, Miss Tracy. Good evening, Miss McPherson. Glad to see you here. And as we always say, try your best to participate. All right, and that's just a review question. So let's go straight ahead into it. For the persons who were not here last week, I'm going to run through the principles again quickly. All right, so a recap. A bearing is defined as the angle measured in a clockwise direction from a north direction. Bearings are used to represent the direction of one point relative to another point. And last week, we went through all of those schematics right there. So note 12, bearings are written using 3 digits. So example, a bearing of 5 is written with 005. A bearing of 75 is written as 075. Angles are always measured in a clockwise direction. Angles are always measured from a north line, The word from is used to represent the starting line. A sketch based on the information is always required. North represents 0 or 360 degrees. East represents 90 degrees. South represents 180 degrees. West represents 270 degrees. Your sketch must always include the north line, the bearing, which is the angle, the starting point, and the ending point. So those are all the principles that we went through last week, which are the basics to bearings, which you need to know in order to answer one of those more complex questions. Good evening, Mr. Crawford. I see you. All right, so examples. And I'm going to give you guys a minute to write this example down, because once I start working, I need you to just focus on what we are doing. So from a point P, the bearing of a tree is 60 degrees. From a second point Q, which is 200 meters due east of P, the bearing of the tree is 330 degrees. Determine the distance of T from P. So everyone write that question down in your books quickly. So this is a more complicated question. This is an exam style question. And so what that means is that you need to know all of your principles for trigonometry, based on trigonometry, in order for you to answer this question. And that means your Pythagoras' theorem, your trig ratios, which are your sine, cosine, and tangent, your sine rule, and also your cosine rule. And so as we go through the different questions, I will try my best to give you a little overview of each of those formulas as we use them for those persons who have maybe never done any trigonometry in depth before, or for those persons who probably do not fully remember all of those trigonometric principles, because they're a good number. All right, let's go here now. And as I said, I just want you to just focus here now on what we're going to do. So everyone should now have the question in their books. So let's read the question and let's now draw our sketch, because remember, each question requires a sketch. If you do not write, first and foremost, you get marks for the sketch. So if you don't draw the sketch, you're going to lose marks. And without the sketch, there's no way for you to get your answer. All right, so let's go. From a point P, the bearing of a tree is 60 degrees. From a second point Q, which is 200 meters due east of P, the bearing of the tree is 330 degrees. Determine the distance of T from P. So this is a complex question here, but we're going to break it down and do this piece by piece. So if you try to draw the sketch by looking at everything all at once, you probably aren't going to be able to do that. So let us look at each piece in isolation and then use that to help us. So the first thing it says is that from a point P, the bearing of a tree is 60 degrees. So from a point P, the bearing of a tree is 60 degrees. So the first thing we need to do is to draw a little sketch based on what we have there. So from a point P, based on what we know the word from is used to represent the starting point. So let's get to our starting point, that's P. So that's my P right there. once you have identified your starting point, you always draw the north line. So that never changes. That never changes. Always draw your north line next. They say the bearing of a tree is 60 degrees. So the next thing we need to do now is that if you don't mentally remember, then on your paper, put your little cardinal points. Remember, north is 0, 90, 180, 270. You want 60 degrees, which is going to lie between 0 and 90. So your line has to be somewhere up there. So we draw our line like that. And that is T representing our tree. You always have to put your angle. The angle is 60 degrees and you start from the north line in a clockwise direction. So 60 degrees right there. North line, clockwise direction. Next, it says from a second point Q, which is 200 meters due east of P, the bearing of the tree is 330 degrees. So the first thing they say is that from a second point Q, which means that Q is the starting point, but they say that Q is what? 200 meters due east of P. So if we use our cardinal points again to help us, right? So if we're in the middle, due east, what does that mean? Due east is directly to the right. So if Q is due east of P, then that means Q is somewhere out here. North represents 0, east represents 90. That therefore means that the angle between the P and the Q, the angle right here from the north line between P and Q is going to be 90. So let me use a different color to differentiate that 90. So from a second point Q, which is 200 meters due east of P, the bearing of the tree is 330 degrees. Again, if we use our cardinal points to help us, 0, 90, 180, 270, 360, 330 has to be somewhere between north and west, which is somewhere up there. And if we draw a line from Q to P, you should realize that that is how it looks. Put your north line at Q because they said from a second point Q, which makes it a starting point. The bearing of the tree is 330 degrees. So start from the north line, go in a clockwise direction. You're going to go all the way around to this line because that's the line that connects the T and the Q. And they say the bearing or the angle is 330 degrees. So make sure you put that 330 degrees right there. So that is how your sketch is supposed to look. Good evening, Miss Talia. So the question wants us to determine the distance of T from P, which is this line right here. But the first obstacle we faced, which is the first obstacle you're always going to face in a bearing question, unless you're given the sketch, is to produce the sketch. Okay, let's now try to answer our question. They say that the distance between P and Q is 200 meters. So put your 200 meters right there. And let us look at our angles to try to see if there's anything that we can do. This angle right here is 330 degrees. Is there anyone who can tell me what do you think this angle right here on the inside that I'm going to mark in black, what do you think is the size of that angle? Based on what we have done so far. Firstly, you need to try to remember what type of angles are these. And then you use that principle to try to find this angle. And we're taking our time through these questions here because we're not rushing these. In a couple weeks time, there will be a marathon that you guys can sign up for where you'll get so many more of these questions to do. So for tonight, we're just taking our time to go through the principles to show you how the basic principles can be used to help you to answer these complex questions. And then give you a chance to see that they're not as difficult as you might think they actually are. So that whenever you're doing your own practicing or whenever you're in the marathon or whenever it's exam time and you see a question like this, you'll have more confidence in yourself and your ability to be able to get that answer. All right, so I see some persons giving me an answer here. And remember that the persons in Zoom, I'm also expecting you to give me answers as well. The persons who are here live in Zoom, you can either use that chat function as well. Right, so if your background is a bit noisy and you can't really unmute your mic, you can still use that chat function as well. All right, so when I look in my YouTube chat, and when I look in this chat, I see persons saying that the angle right here is 30 degrees. Let's check to see if that is actually correct. So people are saying that this angle that I marked in black is 30 degrees. Firstly, we need to draw for the principle. What's the principle? We know that angles at a point add up to what? 360 degrees. So if we're already given an angle that is 330, all I have to do is to take that from the 360, and that gives me the answer for the angle on the inside. This angle on the inside is indeed 30 degrees. So well done to all those persons who figured that part out. Let's go to this part over here now. Remember that the angle in yellow represents the bearing that they gave us in the question, the bearing of the T, the tree from P, which is 60 degrees. That's what that angle in yellow represents. And then the angle in blue, which is our right angle, represents Q being due east of P. Using what we see right here, can anybody tell me what do you think is the answer or the size of the angle that I'm going to now mark in green? The angle marked in green, what do you think is the size of that angle based on the information that we have right in front of us? And when you're approaching a question in C.X.C, you can, whatever you're going to do or the method that you take is based on the information that you're given. Not because you're doing trigonometry doesn't mean say, oh, I have to use sine, or I have to use cosine, or I have to use trigonometry, I have to use tangent. No, it all depends on what you are given. So make sure that you think about what you're doing first and you can explain it to yourself. Sometimes you hear people talking about people who good in the maths kind of mad because them talk to themselves. It's not because we talk to ourselves, it's just that because before we work out anything, we kind of sit down and we meditate out first and we say, all right, then, oh, this is the work and why am I doing this? Because if you can't tell yourself the reason why you're doing something, then that means that you don't actually know what you're doing. If you're working with a question and you cannot explain the reason behind why you're using that method, that means that you have not fully understood or you do not fully understand what you're doing. All right. So let's go here again now. I see people telling me that the angle right here is 30 degrees. For all the persons who said 30 degrees, you are perfectly correct. And why is that 30 degrees? A right angle is equal to exactly 90. If from right here, if the angle in yellow, which is just from right here to here, is 60, and the angle in blue, the right angle covers all of this, then obviously this little piece right here is going to be what I get when I take that 60 from 90, and that is 30 degrees. Because we're doing bearings, remember that you have to use your 3 digits because C.X.C. will look for that. If you do have the 3 digits, then I gonna mark you down. And you see, because this year the exam might be a little bit different, they are going to, or they might shorten it or something like that. They're gonna try to look for every single thing for mark you down. So try your best to do give them a reason to mark you down. All right, let's continue now. So we are not finished as yet, you know. Let us look over this side again now. So I'm going to ask you people a question, and I just want you to picture this, right? Let us say that you are standing in a line. So so imagine yourself in a line, and you can say there is somebody to your right, and it doesn't matter who you want to make the person that is to your right. So it can be your brother, your sister, your mother, your father, anybody at all. All right. Just say that there is somebody to your right. The person who's to your right, if we go to our cardinal points up here, if you are in the middle, the person who is to your right is going to be to your what? To your east. But then if we think about it from the person's perspective, so if you now put yourself in the person's shoes, they are going to be in the middle, but where are you going to be relative to them? You are not going to be to the east of them or to the right of them, but you are going to be to the left or to the west of them. All right. If we think about west represents how much degrees? West represents 270. So if I start at the north line and I go around to west, do you know how much degrees that is? That is 270 degrees. So if we start at the north line and we go to right here, because this is the line that connects Q and P is west of Q, that means that I'm going to use green now. This angle in green would be representing 270 degrees. This is what I want people to try to figure out and tell me now. And let's see what other color we have. We have yellow, so let's use the yellow. The angle in yellow on the inside, what's the size of that angle? So the angle in yellow on the inside, what's the size of that angle? Let's see who's the first person in chat anywhere who can give me that answer now. I see some answers. I see Mr. Levy with an answer there as well in YouTube chat. I see some persons in Zoom giving me answers. I see Miss Aziki giving me an answer as well. Let us look at the principle right here. So I see different answers, and I love the fact that I'm seeing different answers. What does that mean? That means that we're thinking different things, and that means that when I now explain it, I can be addressing everybody at the same time. All right. So I think I got 4 different answers, but obviously it's only one right answer. So everybody pay attention so that we can see where we are going wrong here. So remember, we want the angle in yellow, which is this piece on the inside. If we think about what type of angle this is a point, which means that all of these angles right here. So if I make one complete revolution right here, all of this is 360. But let us look at what we have. And do not let all of these different angles confuse you. That's the reason why I tried my best to use different colors so that they can stand out differently. If we look at the complete angle, you would realize that I can get the complete angle by using the 30 and the 330 here. Yes, cool, but that's not what we're focusing on. We're focusing on the angle in green, the angle right here, but then this 30 is also a piece of it. So I realized that I saw some persons telling me 90 degrees, which should have been 270 from 360, but that means that you are not taking this 30 degrees into account because the 30 degrees is a part of it. And I did not ask you for this angle. Let's use black. I did not ask you for this. Nope. I asked you for the angle in yellow. And the angle in yellow would be the 270 and the 30 from 360. So what's that going to be? 270 plus 30 is 300. When I take the 300 from 360, what do I get for my answer? I get 60 degrees. And remember, please, you're doing bearings. They are looking to see those 3 digits. All right. So when you're doing this in the exam, it's the same way how you're going to have a lot of angles on yours, but if you can try your best to not get confused and just take your time to work it out, that's the same way how you can reason it out the same way that we are doing this now. All right. So for all of you persons who said 60 degrees, well done. For the persons who said 90 degrees, that's a common mistake because you are just focusing on the 270. You're not thinking about the 30, but you have to think about everything. All right. So I did not ask you for all of this. I only asked you for this little piece on the inside. So you have to take the 30 into account. Let's continue now. After you have done all of that, what do you now realize? And remember what I tell you about mathematics and in C.X.C, there is many different things that you can do with a triangle and with trigonometry, but what you do depends on what you see in front of you. Remember that the question wants us to find TP, which is this side over here. But before we can find that side, we're trying to fill out as much information in the diagram as we can so that we can try to see what we can then use to find the TP. All right. So let's look at this right now. I don't know if anybody sees it, and as well, and I hope that the persons who got the incorrect answer, I hope that you guys understand why we got the 60 here. All right, so let's continue. I wonder if there's anybody who realizes what is happening right here with the triangle. Focus on the triangle now, and I'm going to give you guys 1 minute to see if there's anyone who can tell me what do you realize about the triangle. Right? Is there something special about this triangle? Is this a special triangle? And again, try to focus only on the triangle. So try to focus on the triangle, focus on the angles in the triangle, and try to see if you can figure out if this is a special triangle and which special triangle this is. Because if you were in the exam and you don't see that, then you're probably going to make it more difficult for yourself to be able to work out the answer. All right, so let me now address this. So if I focus on the triangle, I would realize that this is a 30-degree angle. This is a 60-degree angle. Oh, this is a 60-degree angle, and I just saw Mr. Levy tell me the right answer, which is the fact that this is a right angle triangle. And how do we get that? As I was saying, this is a 30-degree angle, and this is a 60-degree angle. The fact that we have 2 out of the 3 angles means that I can find this angle at the top at T. How do I find that angle? If you have a triangle and you have 2 of the angles, you can always find the next angle by taking this the difference of the sum of the other 2, meaning that you add these 2, then you take it from the 180. 30 plus 60, 90. When you take that from 180, what do you get? 90 degrees. What does that mean? This is a right angle. And if that's a right angle, that means this is a right angled triangle. Right, well done. That means that's a right angled triangle. Remember, bearings, your bearings question is going to come under the topic geometry and trigonometry. So that means that to get your answer, you have to utilize one of your trigonometric principles. So we have still not figured out what the question wants us to find. All we have done is just to use our diagram to try to fill out some information. But now, since we have filled out everything that we can in the triangle, let's now focus on trying to figure out the size of the, the length of this side that they actually want us to. The fact that we have a right angle triangle, what that now does is that now limits the options that we can use, and it makes it easier for us to be able to figure out what the things are that I can probably use to get my answer. In trigonometry, there are 4 different principles that you need to know: Pythagoras theorem, trig ratios, sine rule, and cosine rule. Those are the 4 things. However, they are split into 2 sections. There are 2 of them that you use when you have a right angle triangle. There are 2 of them that you use when you have a non-right angle triangle. The fact that we see a right angle triangle here automatically eliminates sine rule and cosine rule. So that means that we don't have to use sine rule or cosine rule. Perfect. What does that therefore mean? That then therefore means that we are either going to use the Pythagoras theorem, or we're going to use trig ratios, which is sine, cosine, or tangent. The problem that some persons have is that they do not know when to differentiate between what. When do I use this one? When do I use that one? I'll give you a simple tip that you can use now to know. When do you use your trig ratios basis? When do you use Pythagoras? You can only use the Pythagoras theorem if you are given a triangle, which is a right angle triangle, firstly, and they give you 2 of the sides to find the next side. So you have to be given 2 sides to find the next side. What do you realize? It says nothing about an angle. It doesn't say nothing about an angle. So to use Pythagoras, you don't need an angle except for a right angle triangle. So you don't need to know any of the acute angles right here. In order for us to use the trig ratios, which are our sine, cosine, or tangent, we have to get a right angle triangle, and we have to know one of the angles on the inside. So when you now have the angle on the inside, that is when you're going to use either sine, cosine, or tangent. All right? That is when you're going to use either sine, cosine, or tangent. So for this question, who can tell me what are we supposed to use? Trig ratios, which is sine, cosine, or tangent, or are we going to use Pythagoras? So which one? All right, I saw someone saying that we're supposed to use the trig ratios, and if that is what you're thinking, then you are perfectly correct. You are perfectly correct. Why? If you look at the triangle that you have, if you look on the inside, we are given our angles. We are given angles, so that means that yes, trig ratios is what we're going to use. We cannot use Pythagoras because Pythagoras does not utilize angles, and plus we do not know what the other side is. All right, so for trig ratios, you need a right angle triangle. You need an angle on the inside. They're going to give you one of the sides, like let's say 10, to find the next side. And this triangle satisfies all of these conditions. All right. When it comes to trig ratios now, the major problem that people have is, sir, I don't know when to use sine. Sir, I don't know when to use cosine. Sir, I don't know when to use tangent. I am always guessing. Mathematics is not a guessing game, right? There are certain things that we can use to figure out what to do. So I always tell students that if you are not able to mentally label the right angle triangle, then label it on your paper. And that means that you need to know the different sides. And what are the sides of a triangle? The hypotenuse, which is opposite the right angle. So this is the right angle. This is always the hypotenuse, and that never changes. The opposite side, which is opposite the angle that you are focusing on, because you can have 2 angles. So whichever angle you are focusing on for that question, the side across from it or opposite from it, that's the side that we call the opposite side. And then the next side is called the adjacent. So all you have to do is just to focus on always being able to identify the hypotenuse and the opposite. The next side is always going to be the adjacent, right? If you can't label a triangle, you can't do trig ratio. So this is very simple, but it is one of those very important principles that you have to know, right? The next thing that I tell students is that if you're not going to remember it, then write this on the paper. So katoa. So a lot of persons here, teachers talk about this when they're teaching trigonometry, but they don't understand what this thing stands for or what these stand for. All right. If you realize you have O, H, and A, opposite, hypotenuse, adjacent. Once you know the sides, what the sides are, and once you know what these are, then you are able to always figure out if you're using sine, cosine, or tangent. So let's go here now. Let's now focus on our triangle in question. Again, we have two different angles. That means that we can get our answer using any out of these two angles. All right, so any out of these two angles. Remember, the opposite side is the side that is opposite the angle in question. So if I am using the 30-degree angle, then the opposite side would be this side, because that is the side opposite the angle I am talking about. If I am using the 60-degree angle here, then the opposite side would be this side, because that's the side opposite the angle that I'm talking about. All right, in respect for time, I'll just do this using any of the random angles. Let's see, let's use a 30-degree angle. So let's use a 30-degree angle. If we use a 30-degree angle, that means this side is my opposite side. So that's our opposite side. This is the right angle. And as I said, the hypotenuse is always the side opposite the right angle. So that means that this side is my hypotenuse. And then the side that remains is called the adjacent. What do you now realize here? And for those persons who have never done trigonometry before or don't remember their trig principles, what do we do here now? You look for the sides that have the different numbers or the different sides on it that are given or that they want you to find. Meaning, when I go here, I realize that my 200 is on my hypotenuse, my x is on my adjacent. That is where you now use so katoa. So let's look at so. If I use so, and I'm just doing this once for those persons, as I said, who probably might have a little issue with trig so that they can get an idea of what to do in the exam. So let's look at so right here. So S stands for sine, and if you look on your calculator, you'll see that sine. I hope everybody has their scientific calculator. You'll see sine. O stands for opposite, and H stands for hypotenuse. What does that mean? The only way for me to use sine here is if I have something on my opposite and something on my hypotenuse. Is that what I have? No, there is nothing on the opposite. I see 200 on my hypotenuse, but I cannot use sine. Let's try tau. If I try tau, T stands for tangent, O stands for opposite, A stands for the adjacent. So in order for me to use the tangent, they have to give me something on my opposite and they had to give me something for my adjacent. I have nothing for the opposite. I see that X is on the adjacent, but I cannot use tan. So therefore, that means that I am going to be using cosine, C, so C stands for cosine, A stands for the adjacent, H stands for the hypotenuse. And if I go to the triangle, A stands for the adjacent. On my adjacent, I see the X that they're asking me to find. H stands for the hypotenuse. On my hypotenuse, I see the 200 that I was given. So that means that the trig ratio that we're supposed to use is cosine. So let's now write out the formula. The cosine of an angle is equal to A, the adjacent, over H, the hypotenuse. Let's substitute. The cosine of the angle that we're using is the 30-degree angle. So the cosine of 30 is equal to A, the adjacent, we have that as X, over H, the hypotenuse, we have that as 200. You are solving an equation, which means you want the variable or the letter on a side by itself. So I am going to transpose the 200. When I transpose the 200, I am going to get 200 times the cosine of 30. That is equal to X. Can someone now plug that in their calculator and tell us what is our answer for that? All right, have you gotten the answer? All right, so I see some answers here. And for those persons who don't know how to use their calculator to get that, it all depends on the calculator that you have. Not every calculator you're going to say 200 times cosine 30. For some calculators, you're going to have to put in the cosine 30 first and then multiply the answer that you get by 200. Right? So it all depends on the calculator that you have. And that's the reason why teachers always recommend students get their calculators early and then practice how to use them to do their different things that they need to do, so that when it is time for you to do it in the exam, you're not trying to figure out what to do or you're not doing the incorrect thing. And so the answer for this question here, 173.20 meters. All right, I see some persons with those correct answers there. Well done, well done, well done. Miss Woolcock, Miss Tracy, Miss Rankin, I think if I'm pronouncing that name properly. So some other persons in our chat as well. So well done to everyone who was able to get that answer perfectly fine. And as I said, we're just using today to just go through the principles that you use to answer a few of these complex questions. All right, we're not rushing to go through anything, because instead of me rushing to do 5, 6, 7 questions and you're lost at the end, I'd rather us do only 2 questions and you feel more confident in yourself to try a couple of these questions on your own. And as I said, we're going to be having a marathon in a couple of weeks, and in the marathon, you'll get a lot more of these questions to try, but at least then you should have more confidence in your ability to be able to do it. All right, let's move on to our next question now. And again, pat on the back to for those persons who were able to get that question perfectly fine. It's just about doing your principles of math. And as you can see, once you follow your principles, you're able to get your answer. So again, let's start by making you write down your question here. So write down your question so that when we start working it out, you can just focus on paying attention to what we're doing. And this question is probably going to take us to the end of the time, because on the last 20 minutes or so, Mr. Bernard is going to do a little quiz, a little interactive quiz with everybody here, so that you guys can get a chance to interact and get some other stuff, get some other questions to do as well. As I said, we're just taking our time here to go through these, making sure you see the different principles. So the first question that we did, we utilized trig ratios. I went through how to know to do it and what it is. This question here, now we're going to have to use both the cosine rule and the sine rule. So you will get a chance to see how to identify when to use a sine rule, how to identify when to use the cosine rule, and as well how to actually use them. So another minute, and then we start looking at the question here. I see someone asking about circuit theorem. You don't have to worry, we'll touch a few of those over the weeks before exam. So you'll get a chance to see how we break down those principles for that topic. But everyone should have that question written. So let's look at this question now. So it says, a boy leaves his home and travels 5 kilometers on a bearing of 60 degrees to the mall. From the mall, he travels on a bearing of 120 degrees to the school 2 kilometers away. Draw a sketch to represent this. How far is the school from the boy's house? What is the bearing of the school from his house? All right, so how do we approach these questions here now? You start by breaking it down and doing it piece by piece. The first piece, it says a boy leaves his home and travels 5 kilometers on a bearing of 60 degrees to the mall. So remember, every sketch that you do requires a couple things. The bearing, which is the angle, the north degree line, it requires your starting point, it requires your ending point. All right. Remember that our starting point, we usually know our starting point using the word from. But if you look right here, the first part of the question does not use the word from. However, we don't need the word from to be able to figure out what the starting point is here. It says that he leaves his home. And if he is leaving his home, then that means that his home is obviously the starting point. So the starting point right here is H. H. Once we have our starting point, our north line, we draw that. They say he travels 5 kilometers on a bearing of 60 degrees. North, south, east, west. So 0, 90, 180, 270. 60 degrees has to be between 0 and 90, which is north and east. So your line is somewhere up there. So our line is going to look something like that. They say 5 kilometers. And the angle is 60 degrees. I think I'm going to need some more space. Let me draw it a little bit to the more down and to the left. So again, north line, 60 degrees, 5 km. And your angle is always measured north clockwise. So that's the first part. The next part says, from the mall, hold on, let me write M to represent when he reaches the mall, so he has reached the mall. It now says, from the mall, he travels on a bearing of 120 degrees to the school, 2 kilometers away. So let's look at that right there now. Firstly, 120 degrees. This is 0, this is 90, this is 180, 270, 60. So if we want 120, it has to be somewhere between 90 and 180. So our line is somewhere down there. So from the mall, that means the mall is going to be our starting point here. Draw your north line because that's always necessary. And then we said that our line has to look somewhere like down there. Put in my angle first. The angle is from north clockwise. North clockwise. So this is 120 degrees. And this is representing my M. Down here is school. So let's check this now. A boy leaves his home and travels 5 kilometers on a bearing of 60 degrees, 5 kilometers to the mall. Cool. From the mall, he travels on a bearing of 120 degrees to the school, which is 2 kilometers away. So the only thing we have not added is our 2 kilometers. It says draw a sketch to represent this. That would be what we have there. Part B now says how far is the school from the boy's house, which means they want this line. And if they want that line, that means when we draw this line, what have we just done? We have just completed a triangle. And as I said, every bearing question is based on trigonometry. Trigonometry is all about triangles. So that's the first thing they want us to find. All right, so the thing about trigonometry here, as I said, is that in order for you to use the sine or cosine rule, you have to know it. You have to know when to use either of them. All right, so in order for you to answer the first question here, you're going to have to utilize what we call the cosine rule. One of the easiest ways to know that you can use or you are using the cosine rule is that for you to use the cosine rule, let me draw another triangle. So for you to use the cosine rule, You have to be given two sides. Let's say one is 10, one is 11. And the size of an angle in the middle, let's say this is 100. And then they ask you to find the side that is opposite to the angle. If we look at what we have here, what do you see? One side over here, one side over here, 10, 11, and the side opposite to the angle, which is x here. So what is the only thing that we're missing in this triangle that we have over here? Who can tell us? Okay, and I see someone said the angle in the middle. All right, well done. So the angle in the middle right here is what we're missing. So that means in order for us to use the cosine rule, we first need to try to figure out the angle in the middle right here. All right. And that's the thing about C.X.C here. Even though they want us to find this side, usually they ask us to do something else first before we're able to find what we actually need to find. So we want to find how far the school is from the boy's house. School S is house H. They want us to find this. The way how I see, just from looking at the diagram, the fact that it is similar to this, we know that we're using the cosine rule, but we realize that we do not have this angle in the middle. So let's try to see if we can figure out anything here. All right. When I look right here, remember that when you're doing bearings, your north lines are going to represent parallel lines. Right? So your north lines are going to represent parallel lines. Remember that two angles on the inside of parallel lines, inside interior, co-interior angles are supplementary. That means that when I add them together, they have to equal to 180 degrees. If I look right here, north line, those are representing your parallel lines. I have two angles on the inside here. The only difference is that I know what this angle is, but I do not know what this angle is. Right, so I know what this angle is, but I do not know what this angle is. So how can I find this angle? If co-interior angles are supplementary, which means they add up to 180, that means in order for me to find my next angle, I have to take this 60 from the 180, that gives me 120 degrees. So my angle right here in blue is 120 degrees. Remember that the angle that we want to find is the angle on the inside right here that I've marked with green. The angle inside there marked with green. I hope we have realized from looking at the diagram that this is an example of what we call angles at a point. And angles at a point add up to 360 degrees. So if I have this, which is 120, and I have this, which is 120, I can then use these two to find this missing angle right here. So 360 degrees minus, when I add 120 and 120, that gives us 240 degrees. When we take 240 from 360, we get back 120 degrees. My angle in the middle is 120 degrees. All right. So we now have everything that we need to use the cosine rule. All right. So for those persons who have never seen the cosine rule before, or they don't remember, Let me start by writing out the formula. The formula for the cosine rule is a squared is equal to b squared plus c squared multiplied by, sorry, not multiplied by, minus 2 times b times c multiplied by the cosine of the angle marked A. In mathematics, common letters are used to represent sides. Capital letters are used to represent angles. So a squared is equal to b squared plus c squared minus 2 times b times c. We use brackets to show multiplication multiplied by the cosine of a. And I'll be working this question through and showing you how you can use your calculator to get your answer. So let's work this out quickly. Firstly, A, common A is representing a side. What side do we use to represent the A here? You always use the side opposite the angle. So X is the side opposite the angle. That means X is going to be A. So that means I'm going to get X squared equals B and C simply represents these two angles here. B squared plus 2 squared minus 2 times B is 5, C is 2 times the cosine of the angle. The angle that is in the middle is 120 degrees. So that's the first thing right there. You have to be able to substitute your values into your formula. Next, all you need is simply your calculators and your knowledge of how to work this out. So everyone get your calculators for me, please. Make sure you have your calculators, your scientific calculators. So now we're going to have x squared is equal to, what is 5 squared? And 5 squared means you multiply 5 by itself 2 times. That's what that little small number means. You multiply the number by itself 2 times. 5 times 5, 25, plus 2 squared, 2 times 2, 4, minus 2 times 5 times 2, that gives us 20, times the cosine of 120. Right? When we work this out, we get x squared is equal to 25 plus 4, 29 minus 20. So what you do now is that you now plug all of this into your calculator. 20 times the cosine of 120. When you do that, you should realize that you get negative 10. Right? And in mathematics, whenever you have two plus signs beside each other, you can replace them. Two minus signs beside each other, you can replace them with a plus sign. Positive times positive, negative times negative gives us a positive. So x squared is equal to 29 plus 10, 39. And then how do we get our answer here now? X is now equal to the square root of 39. Plug that into your calculator. When we plug that into our calculator, what do we get? We get x is equal to 6.24. So we can replace our x there with the 6.24. All right, Miss Aziki, I saw you getting that 6.24. I saw different persons telling me that the angle on the inside here was 120. All right, so got to see you guys getting those things working out perfectly correct before I even get my answers. And then we have one final question to look at here now tonight. Question C, which says, what is the bearing of the school from his house? So what is the bearing of the school from his house? All right, so let's clear this. All right, remember that bearing means angle, so it's representing an angle. The bearing or the angle of the school from his house means we have to start at his house, north line. A bearing is always measured from north clockwise, so we have to go that way until we reach the line that is connecting the house and the school. So that means the angle that they're talking about is going to be the angle in blue here. So the angle that they're talking about is going to be the angle in blue here. However, you should realize that the angle in blue here, part of the angle in blue is actually the angle in yellow, which is 60. So that means that if I want to find the angle in blue, I just need to find the little piece on the inside. So you just need to find that little piece on the inside, which is our angle in red on the inside. So we want to try to find the angle in red on the inside. All right, so let me just go through this quickly. So what we're going to use to find that angle is going to be our sine rule. And how do you know that you're using the sine rule? So in order for you to use the sine rule, you need to have an angle opposite to a side and another angle opposite to a side. So I know this angle, I know that side, I know this side, but I don't know this angle, but I'm going to use the sine rule to find it. So the sine rule basically says A, which we should know represents a side because it's common A over the sine of angle A is equal to B, which is a side, over the sine of angle B. And so A is simply representing as one of these sides, and B is simply representing the other side. So all you need to do is that you just identify the side and angle that you're using. So I'm using 6.24 and the angle opposite to it is 120. So I'm going to have 6.24 over the sine of 120. And then this is the angle that they want us to find, and this is the side that goes with it. So that is equal to B, represents a side. So the side 2 has to go on the top over the sine of angle. What do we want to call it here? Let's call it H. Or let's call it X, since that's what we don't want. That's what we don't know. So let's call it X. What do you do here? You now cross multiply. When you cross multiply, what do you get? You're going to multiply these two things together. and you're going to get the sine of x multiplied by 6.24 is equal to 2 multiplied by the sine of 120. Because we want to find x, we're going to transpose the 6.24, which is basically going to work out to the same thing as dividing both sides by the 6.24. So 6.24, divide this by 6.24. That's going to cancel. When you work that out, you're going to be left with sine x is equal to, when you plug that in your calculator, you get 0.278. Oh, by the way, Miss Tracy, sorry about that. How did I get 10? Because I multiplied 20 by the cosine of 120 for that question. So if you multiply 20 by the cosine of 120, you will get negative 10. Right? So what I actually got was negative 10. All right, let's get our answer here now. If sine x is equal to 0.278, how do we get x? X is now equal to the sine inverse 0.278. Sine inverse, how do you get sine inverse? Every calculator has either a shift button or a second function button. When you press the second function button and press the sine, the SINC button, you will see that sign with the -1 on it, which represents inverse. Or if you press the shift button and the sign, then you will see that sign with the -1 on it, which represents the inverse. When I plug that in the calculator, my answer is 16.1 degrees. Which represents the angle on the inside right there. However, if you stop right there, then you're going to lose a mark because that's not the angle that they're asking you for. The angle that they're asking you for is not the one on the inside here, but the big angle blue. And the angle in blue is made up of these two smaller angles in yellow. One of them is 60. The other one is 16.1. So the bearing, the actual bearing that they want us to find is going to be that 60 degrees plus that 16.1 degrees. What is our answer? 17, no, not 17, sorry, 76.1 degrees. That's our final answer. All right, Mr. Bernard. That's going to be
Okay.
my final question with them for tonight.
Right.
Right, so one question where we utilized trig ratios, and then one question where we utilize the sine rule and the cosine rule. So you all got a chance to see how we utilized all of those principles right there. All right, so you can take over now, Mr. Bernard.
Okay then. All right. So we have our quiz coming up, a weekly quiz. So I want to say, well, Ashley, are you there? Ashley, are you there? Miss Martin. Okay. All right. Go ahead, Miss.
Repeat what you said, sir.
You saw I sent you a message? You saw it?
Oh, yes, sir.
Okay, go ahead, please. Yeah, you may go ahead. All right, while Ashay, while you're preparing that, we're gonna get the quiz ready, up and running. So we normally invite those members who are in YouTube to participate in the quiz. So I'm just about going to send the link in both the Zoom chat and also in the YouTube chat. All right. So it is now quiz time. Just turn to the quiz. There are 13 questions, just 13 questions. All right, so the link is in the Zoom chat. So I'm not going to put the link in the YouTube chat. All right, so there are 13 questions in the chat. So we're waiting for waiting for all of you to join the quiz now. So please go ahead and join the quiz. All right, so there are 2 persons already joined, 3 persons. So we have Nikosha Teresa Tangini. Waiting for the others, those from YouTube. You can join us now in our quiz. We have Taj, okay. Still waiting for, we see a lot of you on YouTube, so we should see no less than 20 persons there. Lexi is there. We see that's Prihe Tahelia. Is that correct now, Mr. Foster? Sir
Could you
Foster,
repeat the
there?
name?
That's Tahelia.
Talia.
Talia, okay, good. And we see Gabriel McPherson, one of our winners. So let's see how competitive it will be tonight. Who will win tonight? All right. We see Slimmers. Well, okay. We have 8 competitors still waiting for the rest. So we see from the Zoom team, we have Lexi, Nikosha, Tangini. Waiting on the others to join. Okay, we see Maxine. Where are the others? Where's Tracy? And we see Mahesha. Where's Tracy? Tracy, we are waiting for you as well. We have Aziki. Is Tracy there? What about Levy? Are you there? So we have 11 persons All right, so we're going to start the quiz now. You can still join the quiz even after we have started, but we're going to go with the quiz right now. Let's go.
Mr. Bernard, auto hide the bar at the top so that YouTube can see the full question, please.
It's not allowing me to do that.
Oh, okay.
Yeah,
Okay,
so the
okay.
full- okay. All right, so two persons got it correct. I didn't get to see the leaderboard, but we'll see. So two persons got it correct. All right, so let us go. Oh, it works. Okay. So the area of a rectangle is 53.6 square centimeters. If the length is multiplied by 4 and the width is half, the area would then be. So you have 2 minutes on each question. Okay, let's see what the leaderboard is gonna say to us
Well,
now.
Mr. Bernard, I don't understand how people look at the questions, the time to run down for them. I don't even select one.
Well, four persons get it correct. No man, four persons got it correct, man. Okay, that's good. Well, this is a very tight competition so far. Let's select it, man. The man leaves home at 22:15 hours and reaches his destination at 4:04 hours. On the following day, the same time zone, how many hours did that journey take? You said the avatars represent the persons here, Mr. Foster. Yeah, see. So once you hear the pop zone, somebody selected the answer.
That's me, because I joined the quiz as well.
Oh, you
I want
joined
the
it too.
prize, you know.
Oh, okay.
Yes, Mr. Bernard, that's not fair.
No, not fair. Okay. Leaderboard. That means that you're a lead. Oh, yeah, lead. Yeah, lead in easy too. That means well, we'll set the winner from second down. Okay, we see Tangini, the top 5. This is where you can come and do your quiz. We're gonna try to get all 60 questions on as we draw close to the exams. 60 questions will be on. Wow, Maxine has stepped up to second place. Wonderful. Perimeter of a square is 56 centimeters. What is its area in square centimeters? Okay. All right, keep going. 7 persons got this correct. Okay, wonderful. Following diagram, which is a cylinder, of course, not drawn to scale, of a cylinder of radius 3 centimeter and height 8 centimeters. The volume of the cylinder is. There are 7 questions remaining. Okay, Tangine is now in top 3. Wow, okay. And we still see Maxine in number 2 position. Who's going to win tonight? Will Rasheen lose? We have 6 questions to go. 12 minutes left. Okay, leaderboard. Okay, Teresa is stepping up, top 6. And 8 persons got this correct. Well done. Remember, these are the paper one C.S.E.C measurements question. And we are about a month and a half away from the exams. So come each week to test your knowledge to see where you are in your preparation. Wow, Tangini in second place. Okay. Come, folks, gotta step up. Step up towards the number one position quickly. You have 4 questions remaining. Okay. All right. So we have 3 questions remaining. This is an easy question, very easy question. The volume in cubic centimeter of a cube of edge 3 centimeter is. This is the easiest question in the quiz. Okay, Maxine has come taking over second. Well, this is a high competition. We have two more questions remaining. Hmm. Two more questions remaining. Who will be the top three? Figure above mapped on the scale shows a sector of a circle center O. The length of the minor arc PQ is 8 centimeter. What is the length of the circumference of the circle? Taj is now in second. Very good. Very tight competition. Well, we have one more question to go after this. Let's see what the top three winners will be. One more question to go. All right. So we have come to the end of our quiz. And let us look at who the winners are. So we're now at the end of the quiz. Okay, we must say congratulations to Taj and Maxine, but Mr. Shane, congratulations to you too. Okay, congratulations to all winners and congratulations to all the persons who have participated. Um, I hope you recognize where you are, where what you need to work on and so forth. So we have persons who have answered 61% Taj, 69% Maxine, and well tried Tangini, 53%. Well tried Tangini, well tried Lexi, well tried Teresa, and of course Nikosha. And well, Gabriel, you have to step up to the plate next time. So congratulations to all of you. Now, as usual, when we come to the end of our session, we ask for persons to evaluate the night's class. So, like for you to say, how was our class? How was the class for you tonight in the YouTube chat? And of course, those in YouTube, those in Zoom, I normally ask you, how is the session? Ashay, are you there now?
Yes, sir, I'm here.
Could you go ahead and do what the task that was asked of you, please?
Okay, sir.
Mhm.
Good night, everyone. I want to give a special thanks to Mr. Rashane Foster. It was indeed a great pleasure having you here with us. I want to thank you for sharing with us the tips to make optimal use of mind power and inner potential. Once more, I want to thank you for having spared of your time, precious time, to be here with us.
You're welcome. You're welcome. You're welcome. And Mr. How much percent did I get, Mr. Burner? Because I never did one question. Did I get everything else right? By the way, I think so.
Mr. Foster, I won't say. Mr. Foster, I won't say. I will not say what you got, Mr. Foster.
No, I was just testing out the quiz, that's all. So,
Okay,
so
okay.
disregard my scores, people. Don't watch my score.
92%, so you got 8% wrong. All right. So Tangini says that she learned something new and also grasped more on the topic. So thank you very much for that, also, Tangini. And I'm yet to see persons from the YouTube uh, to share their how they felt about the class tonight. And what about you, Lexi? Lexi, are you there? All right. Well, all right. So next week, Monday, Lexi says that class was good. All right. Very good. So next week, Monday, we will be continuing with our Monday night classes. And of course, Mr. Foster will be here again with us. And of course, on Thursday nights, the registered students will be having their Thursday night's class. So please, guys, come early. Get prepared for class so that we can have another good time again. And of course, we also want to say thanks to those persons who have participated in the class from the start to the end in the quiz competition during Mr. Foster's class. I want to say a big thank you to you all. So just want to wish you guys a good night and see you same place next week, same time. So do have yourselves a wonderful night. Mr. Foster, thank you very much again, sir. Your mic is muted. All right, so that's it. All right, guys, have a pleasant good night. Take care. Okay, but before you go, we are seeing Perry say that this was an eye opening for me. Okay, then, ma'am. All right, so we see that Tahila said that there's an eye opening for her. All right, very good. And I hope your eyes will keep opening. And of course, we look forward for more expertise from Mr. Foster. And we know that you all will do well in your exams when the time should come. Oh, tell us that our mom beat her. Okay, then. All right. All right, so that's it.
She let her mom beat her in the test.
Can you imagine? Okay, we said Gabriel is also saying that, sir, I understand the topic now to the point where I can explain it to my peers. Thank you. Kudos, Mr. Foster. Kudos to you, sir. Well done, well done, well done, well done. All right. All right. All right. Mr. Foster, I'm gonna leave it to be the host. Okay, sir.
All right, sir.
All right. Hold on there. Mhm.
All right, so good night, everyone. Have a blessed night. As said before, it was my pleasure to be here with everyone. I hope to see everyone here next week when we start a new topic.
So again,
I haven't decided as yet, but I think next week we will look at some circuit theorems.
can I get that more? Oh, I'm giving what was. I'm gonna stop the stream.